Hello, hi. And actually, this piece of engineering work I worked on sometime last winter. Woke up at 2:30. I said CAGD. I found the Professor Farron's book, the deceased Professor Farron's book, Gerald Farron's book, free PDF file on the internet. Thank you. And to those who published it. And it's really sad that I'm reading it after he's passed away. He's my husband's supervisor. He and another professor, all right, who went to a community college because he couldn't cope with all the demands that a research led life involved, for fun, rat race to get funds, research funds, that sort of thing. So he went to a community college. He's the professor, Tom Ford. So, anyways, so I looked all that up, and I have to actually myself remember what I've done. So, electric car design, all right, just the barest minimum. All right, so I'm going to go to my file. Uh, how does an electric car work? For, of course, after having driven, I think at some point in time, my husband had a Tesla. One of our trips, one of our, so a fuel cell would start off the ignition. This is all first thoughts. The entire electric car would function like an electric circuit operating electrical equipment, like say an electric oven. And how I tried to, how to synchronize lamps, synchronizing lamps. This was one first year undergraduate engineering. This was what I had flunked, then retaken. So the second time around, I did all the electrical circuit connections religiously, and really, learned more. I would like to think, but obviously, it's all gone out of my mind. So, a set of three synchronizing lamps. That's all on the internet, and you look it up. So something like that, I thought, would be for an independent electric car design. This was the first thought. So this bus bar, what a bus bar is, etc. All right. So so fuel cell that converts chemical energy into electrical energy, and so this is all the details of what's on the circuit, synchronizing lamp circuit. So next, so fuel cell, then it took a while. All right. So fine body work. I had, obviously, my husband's precious Passat before I got my leased Mazda Protege, or the stress involved. The man, next to my son, treasured this car, like, and so much work, right? The weekend trips to and fro. My son, my heart and joy and everything. My son, my pride, heart and joy. But he was a bit of a difficult, a little bit, all kids are. So so I, a parking, tough parking space. I have to get this tough parking space. So I hit once, and then another time I'm giving a ride to this teacher of his. He was going to Montessori, my son's second year of Montessori, and the teacher directs me into the outcoming thing from a, luckily no car was coming out of the freeway entrance, but maybe it was blocked for, it was under construction or something, luckily, which was good. So there again, I had to get out. So I saw great body work, Joe's garage, BMAC Auto in Ottawa. If you have something, go there, and he's going to make it look as good as new. Nobody can tell. That's what I like. All right, So yeah, and all right, all this. So stroke piston and cylinder engines, V6, work through the fuel air mixture from the carburetor. And I have a bunch of you can also look up internet websites. The three electrical connections would be an electrically directed V6 engine and the carburetor, and the fuel being substituted by an electrical operator, and in turn the spark plugs would be replaced or would not be necessary with an electrical ignition, and the car battery startup. So this was what this is. I'm going. The bus bars would be operated with a transformer. The synchronizing lamps would be the smoothly running car. All right, once the synchronized, lit up lamps would be the smoothly running car. My first instinct was wrong, and the voltage source would not come from the car battery and would have to be a separate fuel cell source or another voltage provider. To electrically direct a V6 engine that is existent in today's car technology, Since the fuel air mixture is not an option, you would need a smaller battery which is hooked up to an electric motor via an electrical connection or electrical lead. See? I suggest replacing the carburetor with the above. This would be 1 and 2 in the first electrical circuit, and the third would be the car starter battery. Going back to the original circuit, the bus bars would have to be connected to a transformer. And so an AC motor would be necessary to run the V6 engine. So you should watch videos. This would be the transformer, electric car, etc. All the videos. But just punch in car, electric motor, gears, etc. And you get all this. Again, resuming again. This is how slow it's going. On the 23rd of September 2024. I got a nice shot of a car. Mazda Protege this was. All right, so let's show you the nice shot of a car. So just close up. I'll ask YouTube to adjust the parameters. So, you get a nice view. So this is the, of course. So this is the, yeah. Those would be, that would be, yeah. V6 engine. And rather than pump gasoline out of the existing car, it would be simpler to cut off gasoline supply from the, I forget the right term, gasoline supplying hose to the carburetor, replace the carburetor as I've suggested above, a smaller battery with an electrical motor. There is room above, I think. So look, going back, there is room above. The internet says that the car engine V6 or another works in this manner. At the front of the end of the engine, the crankshaft connects to rubber belts which connect to the camshaft and delivers power to the other parts of the car. At the back end of the engine, the camshaft connects to the drivetrain, which transfers power to the wheels. So you will have to process these. I'm not processing this at this time. Besides, I woke up too early, I slept too late. But if you process these, you'll figure out how it's all connected. Look at the picture. All right, put it up on your own computer. A note from me, it is best to retain this mechanical action of the car engine. So this much I suggested for an existing car. Electric car design 2, I haven't yet done the CAGD on it, so that comes another day. And I say that it is best to get an engine wiring harness. It comes all in a package deal. Making space is going to be hard, but car mechanics are car whizzes in ways that engineers cannot comprehend. So part 2 from today, the car battery hooked up to the carburetor substitute, as I've outlined with the V6 engine, is the series connection, and I would need the electrical wiring. The above has, okay. So this I did not use. This was very complex, I thought. I made it simpler. All right, this matrix, etc. A complete method, a comprehensive methodology to obtain electrical analogies of linear mechanical systems. I did not use. I used, what did I use? My next, all right, would be to convert the V6 mechanical system to an electrical analog with minimal changes. That might be smarter, I thought. All right, the existing car technology ensures that the action of the fuel air oxidation in the carburetor gets the V6 engine running. So what we have, right? The gasoline powered car. Since I've suggested replacing the carburetor with a smaller car battery and an electrical motor, the V6 engine would have to have its connections converted to an electrical analog. So I need an electrical wiring harness, etc. Force is equal to voltage. The car engine with existing technology runs with the action of the V6 engine. Would the speed parameters help in the calculation? All right, this is what I'm thinking to myself. I realized from the example in the above, immediately above, reference that this may not be at all necessary, all this. My proposed replacement for a carburetor would power the V6 engine, and in the same breath, coolant may not be required, but instead, as in chemical engineering system, I may need a cooling fan. So that's, mm, um, Let us say this replacement AC motor generates, uh, and please bear with me for I have no idea as to what is the right capacity, an equivalent of 1 liter gasoline oxidizing 1 liter of air, releasing equimolar ratio 1 liter NOx emissions and CO emissions, together. This is an exothermic reaction, and the heat energy is transferred into the mechanical energy. Well, piece of cake if you're a chemical engineer, right? It takes a bit of thinking, but so fuel power stroke. The fuel power stroke is where the heat and energy transfers into mechanical energy. The power of the explosion caused by combusting fuel air mixture forces the piston back down at speed, and this energy is transferred to the crankshaft. The crankshaft turns and transfers its rotational power to the flywheel, which drives the wheels and powers the car down the road. All right. So energy equals force multiplied by distance divided by time. 400 joules equals force. So force equals 400 joules by velocity. Force can be substituted by current, and this can be generated with a proposed electrical motor. And this would drive the piston and cylinder action, but working backwards, I would need an equivalent of 400 joules, and this is an assumed number, but a test drive in the existing car technology would solve these questions. So that's that's electric car design one. So two, all right. So I'm going to go to my next, generating the CAGD design. Okay, the CAGD guru, Gerald Fadden, was a pioneer in CAGD. His book, all right, Fadden.pdf, shall we say, says that computer-aided geometric design can be done with key aspects: control polygons, Bezier curves, spline curves, Kuhn's patch, B-splines and nerves, Bezier triangles. The AI-generated internet source says that both Bezier curves and B-splines are examples of control polygons. Okay, first electrical car design. All right. I have three auto parts to design in shape and size for my electrical car design to work on an existing car technology. Just siphon out or pump out all the gasoline in present in the or it just to make sure that it's not running on gasoline power. All right, this is the electrical car power. All right, the carburetor substitute which works on the two electrical AC motor which will replace the Mazda Protege 2003 V4 cylinder engine. One is a carburetor substitute which works on the two electrical AC motor which will replace the Mazda Protege 2003 V4 cylinder engine. Three is an electrical wiring harness which will have to be downsized to fit in the space. Going back to my research from Dr. Farron's book, I shall compare the Castle House algorithm with the improvement Dr. Farron made with, but my husband and his buddies would cry at the thought. MSXL per plot, because they think, all the software from the company. So this is what lesson I learned the hard way, but my husband is my buddy in a way, because I have, the emails not even reached all these people I've been sending it out to, because they've withheld it. I remember the mutex, etc. I worked on, there's a program and everything, but the company did, get jacked. Billy Bob Thornton in Utah, the company has jacked me. They haven't passed on the email. The email, the system administrator. What do you do with system administrators? Eh? They have a mind of their own. But they didn't want me to get cheated, so I'm publishing this and then submitting it to both the mother company of this company. And my husband wouldn't like it, but he was like, today, stupidity is an art form or something like that to me, because I said I want to buy Maya 3D software student version. It doesn't do these things, it doesn't do animation, it does nothing. Buy something else. And and I waited for him to leave. And I said, stupidity, is it? A stupidity at the highest or height of stupidity or something. And he walked out, and I said, slightly underneath my breath, fuck you. That's telling him off. All right. Okay. The most basic algorithm for Bezier curves. Okay. So you all know the CAGD students. Curves and curves and surfaces in projective geometry. All right, all that. So here is important. I'll write this down and tell you what substitution I made with mathematics, because I have several math courses, 5 or 6, and red for my master protege. It was a red color card. All right, so this is all right. So this is what I took, and I replaced a portion with with an easier math step, so my numerical integration would be easier. Okay, the definite integral, and I refer you to page 626 of the 1983 edition by Krasik, Advanced Engineering Mathematics. And the solution struck me now, and that is z is equal to x plus iy. Is the curve only in the x direction, but you need the y to map the entire curve, and hence y is the imaginary space. Piece of cake, right? You all know this. And then Sm equals sigma uh, n equals 1 to m, f of 2I, as in the Greek letter, and it is equal to z of t. Okay, so this is equal to z, or we'll put out crazy. All right, crazy. Where is crazy? Crazy is on the other side. So page number is given. I thought I would be making it easier, but system administrators, where did my mathematics book go? Mathematics book. Sorry, but this is a lot of work, and I need to get you to understand this. It works both our cases, because class I might be sending it to the right source. So 626. 1983 edition. So z equals, well, so this is it. So the curve C is called the path of integration. And here, so what have I substituted? Z is equal to z of tm. Oh, this is all right. Sm xi m delta zm, and sometimes books somehow change. To it. So this, and you read along these lines and get the math down pat. And so I substituted that, and this is f of z, that is equal to z of t to the base m whole. Oh. And it is equal, and the limit of the sequence is called the line integral, and is denoted by integral over c f of z dz, and the curve c is the path of integration. Applying the same mathematical procedure to the above homogeneous parametrization of the Bezier curve, I have from the formula sheets from the UFT bookstore the trapezoidal method, the Simpson's formula, and the Gaussian quadrature. This would affect the right numerical integration, but I shall choose the first one. So so just numerical integration. All right. So some mathematics involved, but setting up the parametric equation, etc. And so finally the or all you CAGD students with these two tips should figure out how to do the numerical integrations to parametric differential geometry. So because I have no CAGD background, so it was a lot of hard work for me. But for you, it may be easy. And parametric changing, that all the STR, getting it right, and etc. So NURBS and NURBS, Dr. Farron's book says, and etc. So all right. So the curves, nothing goes right without curves. So I have heard. So all right. Bezier curve. Gaines theorem. Okay, wait a second. Let me see what I've called this. The actual design, next day, of the 3 auto parts background. So I connected the 130 horsepower, 2-liter inline 4 engine in the base DX and LX models, and that sort of thing. All right, this is what Marissa Tomei and My Cousin Winnie, the base engine produced by 135 pound-feet of torque at 4,000 RPM with a master speed. A version had 100 pounds of, the New York, Brooklyn accent. All right, I'm not getting Brooklyn accent. I'm getting mathematics here. So a lot space for volume of 2,000 centimeter cube or 0.002 metric cube. From the image I have in my file, the carburetor substitute should fit in where the current carburetor is located, and the wiring harness will have to fit in beside this. And from a rough estimate of the space, etc. This is all basic, fiddling around, and so. So trapezoidal method for curve, Bezier curve 1. This is the curve I got. So the lettering, the curve only. Not bad. I mean, it's not, again, Maya, but this is MS Excel. Did pretty good. Didn't cost me a penny, other than what I had spent before. And then Bezier curve 2. Green's theorem. Green's, this is a separate one. Bezier curve. Two, is there a curve 2? Okay, this is 2. And 3, I think I asked him to work it out with the electrical wiring harness manufacturers, giving the dimensions. Or did I do 3 as well? So this is the curve 2. Which one, if you work out the numerical integration, control polygon, etc., you should get it. So I replaced the tough step with the easier math step. That's all I did. All right, so that was my CAGD part 1, and ZT. So this step I replaced, right? This, and this I did because this is a vector ni. So you have to three of these. So 1 minus t. So taking values. So this would be n minus I square, ni minus I square, um, and then these were all values in Excel, numerical integration values. So this multiplied by this multiplied by this. I think minus comes up. Vectors. Even I don't remember now. All right. So vectors. So that's the only thing I did. And C and T, the other one. I think this I think I replaced this for the mathematical step. You all connected. It's all a little hazy in my memory now. But if you're sitting on a getting into your falling into your lap is not good. Is it? No, it's not good. So anyway, so that part is done. Those of you who do not want the rest of it, please when you're watching the video, feel free to do your own thing. Shopaholic, what I should, I've presented lamps to small babies, newborn babies. I should present um, llama, I thought. It might be nice, right? Llamas are cute. There's this, I read somewhere that there's this llama which responds to English songs. So that might be nice, English songs. So let me listen to a Spotify number, and then the Sexaholic, I'll sing on this llama. By the llama, sing on the llama. Okay, we'll do Coleman Hawking. Llama, llama, llama. His name was Rama, 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 Rama. Now to act in a drama, drama, drama. He wanted to be friends with Barack Obama. Rama loved his mama. Rama, mama, mama. The llama named Rama went to visit Vasco da Gama. Da Gama, da Gama, da Gama. Rama, Rama, Rama. Rama with relish. Looked like a cute dish with bread. A big round of applause to Coleman Hawkins. Thank you.